Hello again to more reverse engineering of PUBG Lite. Today with me, Warranty Voider. So I'm pretty impressed by the progress that Semi made, so I will just continue where he left off. I found one little problem, that he labeled this wrong, because the whole send properties function was actually inlined here, and for compare, this is how it should look like. So the actual send properties function starts with checking some value on any thread and stuff. So here's some indexing, which we can see here, and from some point on it then assigns this variable if it's supposed to do a checksum or not. So that's done over here. I don't know why here's a second compare for this, but yeah, anyway, then we have the write bit if enabled properties, if the macro for it is enabled, which it is, and then we come to the actual function send properties are. Why it's not letting me go there? Okay. So, and in here a lot of other stuff is inlined. This is mostly a big while loop, and because it checks the condition at the first start, it has to do it separately here. Then this is our whole while loop, and yeah. The first thing we do here is getting the command variable, and I already reverse engineered the structure of it, which I got from here. So that's how the structure is defined, and now I can see anywhere where it accesses its properties and which one it is. So, for example, the write property handle starts with getting the numbers from writer parameter, which would be impact. Not sure if this is just wrongly labeled by me, but anyway, it should start here. Then we have the serialized impact with local handle. Yeah, so all of this is already present from the parameters here. So handle iterator, handle iterator, which gives us a local handle, and so yeah, it's inlined. And that's, if we do checksums, we do serialized generic checksums. Okay, look at this, which is also inlined, and it has this nice constant to know we are at the right place. Then we serialize these bytes, that's this call, and the check is probably skipped in the final thing. So from here to here is this function inlined, and this function is inlined from here to here. Just wanted to show why inlining can make the code look different than you would see it in the source code. Alright, so let's continue. And we have, so also this, why we do this little explanation. Obviously for every call that serialized bytes or bits or whatever, we can now see how we got there and where in the code we were. Now with knowing which functions these are, we can make it's easier to understand how the package was created in an abstract overall view. And so we just want to continue this until we have all functions needed in here, or called. There's another problem. Also, we see the packet created in the reverse, because first we have the most inner data, which then gets put into a buffer, which then gets appended another buffer and another buffer, which together all then will be written as a packet. So yeah, this is like traversing a tree from the ends and going to the root. Okay, never mind. We have data here. Here we write a string, for example, which has bytes, and then we have these kind of calls. This is a specific function that is not. How do I copy that quickly? See how quick it can find this. This function gets implemented by scripting code. Okay, that's enough. Just find me this. Always make sure Windows security is off. Real-time protection. If you have that many files open, it would slow everything down. Okay, as you can see, this is a virtual function, so there is not function definition or implementation. Oh, actually, are there implementation? Can I search for implementation? There will be a million references. Not sure if Visual Studio can find these, so stop this search. So anyway, this serializes essentially some data which is of any type. So for different types it will have different implementations, and I'm currently not sure which implementation is which. So instead I made, every time I have such a function, oh yeah, how do I know this is always the same? This comes from send property R. Let's go there. And yeah, I get here because I return from this, and encodes this essentially. So let's look up that function so we know where we are. Yep. Let me quickly. So this happens if the type is not null, not 0. And here the most code is if it is 0. So we can skip all of this and can go to the stuff at the end here. And we come back right before or next to this function call. It would be this. And right before is the one we are interested in. So first off, I can ignore anything that's not included in shipping. Profiler is probably not defined because it's a shipping build then. And so we only have get numbits and then this net serialize item function. Don't get the num end bits, but they are only used in the network profiler and nowhere else, so it's probably removed by the compiler. So only this is left, and probably that's how I should call it. From the property, we call the function to serialize itself. So, and depending on what property type that is, we will have different implementations for these. So here's one It's a different one. Yet another one. As I said, don't know yet which type it is for each of them. I can find it out later. I will also have to find this out when I want to recreate this in Relight later. But for now, I just number them through, so I will have multiple of these that write different types. Another one. Okay, and here we have another unknown. So finally, let's get started and find something new. Oh. Let me guess. It's another one of these functions. Alright. So let's name it then. Number 3. Also, matches to our hints. It should be a very short function. Okay. And I think this was here, which then goes into somewhere else. Do we have that function? Not yet. Have references. You in property. Okay. And what are you? Float property. And you are in 32 property. Okay, they all just use the same. Let me quickly check something. I'm not sure if I can find this. Okay. T property numeric. Yes. Huh. But I don't see any serializing function. Oh, yeah. But that's protected. Quality and serializer, okay. Oh, serialize item, okay. Huh. What? Okay, never mind, but this sounds plausible. And that would be of this class. Which is a pretty long name, but okay. Who cares? So we had int32, int32 and float. And from this, the function name is serialize item. And let's check. In property, float property, and int32. Okay, that is fine. And a pretty long name. T property, okay. How about, because I give this name now, I just call it T property 32 bit. Because it's way shorter and tells me the same. Always look for the NP symbol to know you're at the end address. And there it is. And it's used a lot. Okay, always E60. I already know this is one of these implementations. See if we can find anything out about it. You belong to bool property. Wait, can I find this out for the others as well? Wait. Oh yeah. You byte property. Ah, nice. This will be helpful. Okay. Almost. Okay, who are you? Ooh. Object property base, okay. Soft class property. Soft object property. So a soft property. Weak object. Class property. This is pretty close of what I think. Lazy object. View object property. I guess that's the base of everything. Yeah, I guess I will take that name. Oh yeah, if you put a function name you defined in the comments, you can double click it to get there. So who are you? In num property, okay. That would be this then, because I just skipped one. Still define this. Okay, you belong to a lot. Numeric property. Int 8. Oh, this is a byte. Int 16 property. Who would be the base of all of these classes? Int property. Numeric property. I guess it's already what I'm looking for. Numeric property. Okay. And now the new one I found. Actually, I should sort them. Come on. hide property. Yeah. Enum property. Okay. Numeric property. Nice, this all makes more sense now. Okay, something new. Write content block payload. Okay. View active channel. Yeah. Okay. So all of this data so far will now be written as a payload block. And it's pretty much what we see next. Okay, now this is something different. View channels and bunch. Okay. So many involved functions. Okay, we don't know this yet. We know where it was sent from, or called from. Oh yeah. U channel. Do we have the structure for U channel already? Nope. Let's see. There should be a bit writer somewhere here. Okay, this is weird. Why do I have 4 pointers here? What's A2? Do we have a bunch already? Yeah. Okay. This is a lot, but I can see this is never really reassigned, so I can map it. What's with this variable? Okay, same deal. So now this is used in way more places. More stuff is decoded. Okay, so we wanted to know this place. Huh. Pretty much at the start. Okay, let's see. Okay, this writes something. Yeah. So it should be this function. Okay. Okay. Still not sure about this. It looks like the return value. Huh. Well, okay, maybe they have edited their code a little bit, because that's what we have to expect. Okay, never mind. Let's add this. Okay, so what is this? Okay, we don't know it yet. Oh, this functions, yeah. Ah, sometimes it helps to just press F5 again. So this again has additional parameters. Why that? Okay, let's ignore that. Okay, here's if. What? This makes no sense. So if this is not 0, this is true. Before we call this what? So why do we have this function already? Let me guess, it has, yeah, comments. Okay. Append net field exports. That's not good. Oh yeah, that's big. So I'm thinking this will call some initializer. Okay, let's first find some of the other functions that are called here. Something is set one. Is it? Really not sure if I'm in the right function here. There should be a loop. Nah, I think I'm at the wrong place here. What? Action driver is server. Well, okay, it must be this function, but inside, why it's so different? Serialized bits should be called at some point. Very strange. RDX. Okay, wait a minute. What if this is another result? Shit. I don't know. So this only has RCX and R8. RCX, R8. What the hell is this? So either forgetting stuff here, that's great. R15. How is R8 set here? Okay, what a mystery. R8. This is very confusing. but I guess this was done due to optimization. Here we have R8. It's a sys pointer. Which is no, it's not the sys pointer. E11. And this is called right before. Oh, confusing. Append exported bunches. Oh, this looks more like the thing. Append net field exports. Isn't that what we were looking for? Net field exports, yeah. This right stuff. Oh, this is a oh. Okay. So you are this. You got only one argument. The others are not used. Okay, then this should compile better. Yeah, great. Okay, I'm sure this is cut out. So, I'm pretty sure there's also export bunches. What is it? Okay, outgoing bunches. At least. Sorry for the quick switching, just wanna be sure. Huh. Well, this is supposed to be a bunch. It would make more sense if it's this one. Okay, maybe not. Okay, I'm not gonna look that up. They don't write anything. Okay, let's take a step back. Package map client. Let's backtrack for a second. At the start of send bunch. Here we have this append export bunches. Wait. Never mind. I'm still pretty sure that's a function. Did they just move it into here? Oh, actually, this could have been done by the compiler. Wow, okay, very confusing. So it then does what? Even 16 net weight. Oof. Okay, let's say this is a bunch. This is called with the sys pointer. Okay, just have to say at this point, maybe they rewrote stuff. Otherwise I cannot explain this function. Because this should be called here. And it's possible that it was called before. Maybe here. But then we would have seen this in the log, so no. Alright. Never mind, let's continue with all the stuff we just found out. Yeah, compiler optimization can be tricky. Because sometimes you think you're at the wrong place. Sometimes you think this is just optimized and I don't see how. Okay, so now we are here. package map client. Can already see where this is going. Yeah. Yeah. As expected. Export map grid. Okay, and finally, okay, we don't know this yet. This should be easy. First function coordinate. Okay. Oh, okay. Patch header count. Yeah, this writes something. You belong to nothing, okay. Okay. And we have everything. Okay. So who are you? Unknown. Okay. What? Oh. Ah, okay. Damn, this is a call. Okay, I see my error here. Because this is from new channel and the other is from new package map client. Okay. That would be this call. Remove this name. It's actually this one. Okay. Never mind, I have it here. And you are this. Because we come from here. Yeah. Okay. First off, let's patch it here. This is actually this. Yeah. And now we have this. Okay, so hopefully everything makes more sense now. So first we append export bunches. Append export bunches and then append must be mapped grids. Yes. Okay, and then next one. Okay. Last one before I go insane today. Oh, send raw bunch. We already know this one. Great. Unet connection. This is kind of important function because it gets called from a lot of places. If I recall correctly. So, and then I actually have to reorder stuff here. Still not. Byte. I hope I have them in order now. Okay, whatever. Let's go. And there it is. See if that's true. All right. So, how far can we go now? Right input. Oh, that's missing. Haven't used that before. Okay, that's easy. Okay. And there it is. Really can't stop it, I'm sorry. Right, bits to send buffer. Okay, that makes sense. Unit connection. Right, bits to send buffer. Okay. Interesting. Okay, I will continue with it next time. Thank you for watching and see you next time.